KubeVirt for vSphere admins with Eric Shanks. Hey, everybody. How are we doing this fine evening? Mr. Shanks, it's been a long time since we've seen you.
It has. I used to see you guys at least once a year, like clockwork every year at VMworld. And somehow we just ran into each other, after hours or during hallway conversations or something. And I got used to seeing you guys. And now I don't see you quite as much. And it's kind of sad.
It was interesting when we saw each other at Red Hat Summit in Boston. I was like, I know that guy. Literally like the last time I saw you was at the last VMware that I went to, which was 4, 5, 6. I mean, it was definitely in the before times.
Yep.
So welcome everybody to another episode of vBrownBag. We have some esteemed alumni with us this evening. Mr. Eric Shanks, who, as you just heard, goes way back with the crew. Damien, Mr. Carlson, how you been?
I am doing excellently. I cooked a very great dinner and told my kids to come eat it, and I didn't get any, and then I came into my office to do this. So, yeah.
Okay. What'd you make so good?
So my youngest son wanted like Chipotle, but homemade.
So okay. Made a great dish. I ordered Chipotle.
No. I did like
Yes.
I did like pork carnitas and shredded lettuce, and cooked up some rice and some warmed up some black beans, and just so they could have like their own homemade Chipotle. Because fast food is stupidly expensive, and when you have children, it's like, why am I spending $15 on a hamburger for a child?
Dude, you're not lying. Like, I went to I don't often eat fast food, but we went to a McDonald's, and I got like two value meals, and it was like $25. Yep. There's no value left in the value meal. I was very upset and distraught.
Yeah. One night, my wife and I, we were out late, I think at a concert or something, and we wanted like the Jack in the Box breakfast on a bun thing, which is pretty good, I thought. It's like $25-ish, and I was like, what the hell? I mean, I remember like going to Jack in the Box with $5 in my pocket, getting 2 tacos, and then having change for gas, right? Like, boom. It's weird. But then again, that was also almost 20 years ago, so. And awesome. Cigarettes were $1.99.
And gasoline was 99 cents.
Yeah. You know what? Okay. Legit. I was at Tech Exchange, and I was driving in a car with some friends of mine, and one of the guys in the back, who was, when you get one of the van Ubers and the people in the back have to like shuffle in and you can't get out. Well, right. We convinced the Uber driver that he needed cigarettes desperately bad, and I was the one in the passenger seat, and so he hands me the credit card and he says, "Chris, go get me a pack of menthols." $10.
Yeah. $8 later. Yeah.
One pack of cigarettes was $10. I was like, are you kidding me? Because I smoked 21 years. I quit 21 years ago. And back then it was like $3 a pack. And I was even at $3 a pack, I was like, this is crazy expensive. I got to quit this terrible habit. It's killing me and it's killing my wallet. Now I can't even imagine. Anyway, Chris Licardi, quit smoking. What are you doing, buddy? Okay, quit killing yourself.
And if you were a bargain cigarette shopper like I was, you could get like the Cool or the Newports with a coupon.
Yeah. Okay, we have gone.
We're way off topic. Good Lord, Eric Shanks, save us.
Help, please. So, KubeVirt for vSphere admins. Before we actually get into it, why in 2025 would a vSphere admin be casting his eyes around at different technologies, perhaps, to learn about? Mr. Shanks?
It feels like that question was a setup, and you already know the answer to this, but I'm going to answer it anyway. You can see, and we can see where this spicy hot take probably goes. So from everything I've been hearing, and like I said, you and I, we used to run around together at VMworld for years. And now we don't see each other very often anymore. And it's kind of sad, but like all of those VM admins now are looking at alternatives for VMware. And from most of what I hear, it's because of ELAs and the price of their contracts, right? So I don't know if I'm living in an echo chamber here. I work in Silicon Valley, but I live in Chicago. But that's what I keep hearing from basically everyone I talk to. So I'm assuming people are looking around for price at the moment. But I have a reason maybe they should consider this an opportunity with KubeVirt.
Yeah,
exactly.
So I work for a company that sells a product that VMware customers are looking at, and this is not a commercial. I'm just stating a fact. It's not only the price that is causing people to leave; it's that Broadcom has refused to renew contracts for customers, and also for service providers like channel partners. And so, when you don't have the ability to buy the thing again, it's like it's an existential crisis that you have to go and find something that you can continue to operate on, or you risk a license audit, which I imagine Broadcom will be no better than Oracle, so you probably don't want that.
Mm.
But yeah,
Yeah,
it's a mess. It's a mess. And echo chamber, Eric, those echoes are accurate. Yep.
Okay. So
I mean, that's exactly what I'm hearing too. It's definitely. I mean, the smaller the companies that Broadcom does not want to cater to are the SMBs and the folks that have a smaller amount of licenses, and they're putting the hot coals to the ones that they want to keep around. Is what I am hearing anecdotally. So yeah, now is a fortuitous time for ye olden vSphere admins to think about expanding their technological stack, which brings us to tonight.
Yeah. And so, I, at one point, I worked for VMware. I was a VMware consultant for several years. But I also started, when I was a consultant, I also did work with cloud native technologies. So, things just deploying directly to AWS, for example, using tools like Terraform or Ansible to manage their applications and do the DevOps pipelines and things like that. And I kind of felt there was some sort of a weird incongruency between those two worlds. I don't know if this resonates with you guys or not, but like the VMware world, whenever I was doing consulting, I was talking to people about okay, now we're going to automate the deployment of your virtual machines. How do we update your CMDB? How do we do your change tracking? Things like that. And then when I would flip over and do more DevOps type work, CMDB wasn't usually brought up very often, right? Your CMDB and your change tracking, everything was all done in Git, and there's automated pipelines. And it was like I was talking to two different audiences who had never talked to each other in their lives, right? And it felt very weird to me. So I've kind of lived in both of those worlds. And now this KubeVirt project that's out, that is gaining momentum, seemed like it fit very nicely for my background, right? I've done a lot of DevOps type work. I do Kubernetes type work from the company I work for right now. And I have this past where I used to do a lot of VMware work, right? So I kind of understand those two. And KubeVirt made a lot of sense to me if you're looking at moving off VMware.
Awesome. Well, that sounds like a perfect segue for me to add this. Oh, where did I go? This one. Add it to the stage. There we go. I'll get these.
So we're going to talk about modern virtualization, which is what we typically call, running your containers and virtual machines side by side in a similar cluster. That's typically what I'm talking about. So here's the problem that we've been running into for years now. So we have all these physical hosts, and most companies I was consulting for, I would talk to, had a vSphere stack. Almost everybody, right? Like every environment I went into, somebody had bought VMware, and VMware was running somewhere in that environment. I don't think I ever ran into a customer who had no VMware someplace in their infrastructure, right? But most of their new apps over the last several years have been built as containers. So they've got a vSphere layer, but they also have to have this Kubernetes layer because they're doing cool new DevOps type stuff, right? And they're playing around with containers. And now they got these two different layers that they're working with. And sometimes those two layers are completely separate, right? Maybe you're running Kubernetes on bare metal nodes, and your vSphere, obviously you've got a different environment for that. But in a lot of cases, you were running these on top of each other as well, right? So you have your vSphere layer, and then you would use that to build VMs, and the VMs you were building were Kubernetes nodes, and you would run containers on the Kubernetes nodes. So you're kind of nesting those stacks, right? either way, most companies that I was talking to had something of both of these if they were a large enough company. The problem being, now I have to manage 2 of these different stacks, which means like I have to do performance monitoring. So now I'm using, say, IBM Turbonomic or VCF operations for my vSphere layer, and I'm using Prometheus and Grafana in Kubernetes. And I've got to do logging and auditing twice. I've got Datadog and Log Insight for vSphere, and I've got an Elk stack for Kubernetes, for example, right? And you can build this out, right? And you see that I've got twice as much software to do the work that I need to be done because I have 2 different stacks. So if I'm looking at this as a manager, as an infrastructure manager, I've got budget that I'm responsible for. I'm seeing an awful lot of waste here is what I'm seeing, right? So, the equation has changed for us. So now a cost issue is coming up with the vSphere layer, and I'm still running 2 stacks in the first place. Wouldn't it be nice if I could get rid of some of these? So it's not just the amount of software that you have to license or you have to go buy, right? Now, obviously, if I'm in this situation, I have to go buy things twice, and it's going to cost me twice as much money. But the real headaches are internal and are costs that maybe you don't notice. For example, typically have an infrastructure team or someone who's managing that virtualization layer. And then you have a DevOps team, let's say, or a platform engineering team of some sort, maybe, that's managing your Kubernetes layer. When it comes up for licensing renewals, the infrastructure team says, our licensing renewal is expiring. Let's start the procurement process. And the DevOps team does the exact same thing, probably at the same time of the year, right? For the same solution. They're both looking for a monitoring solution in this case, right? And so they're wasting time as well, right? And this continues with like the tasks that they have to do on a daily basis, right? What happens when we have to declare a disaster? Infrastructure team uses Live Recovery. Side note, Live Recovery will be Site Recovery Manager for me for the rest of my life. I refuse to use Live Recovery in the normal colloquials.
I didn't even know what Live Recovery was until you made that connection. It's always been SRM.
Did they change the name? Is Live Recovery Manager SRM, or is it a different thing?
I think it's like VCF Live Recovery or something. I'm not sure how the naming got messed around, but in this case, when I say Live Recovery, what I mean is SRM.
vRealize SRM. Sorry, that's
they ARIA'd vRealize, yeah.
But then, like, your DevOps team has to do something similar. Like, they may be doing disaster recovery in a completely different way. They're not using SRM necessarily. Maybe they're redeploying their applications if they're stateless, for example, right? Or maybe they have to coordinate. Now the DevOps team has to wait for the infrastructure team to fail over the infrastructure before the DevOps team can then deploy their apps. Like, that, there's a lot of communication that then has to happen. And that means meetings, it means time, it means all this effort that's going on in the background that has nothing to do with like running the business. It's just keeping the lights on, and we're doing it all twice. My suggestion is, if you're in this position where you're running Kubernetes and vSphere, if you're in a situation where you have to get out of VMware, what if we could run both of these stacks in a single unified stack where I'm running VMs and containers together? I just blew Chris's mind. This is great.
Yeah, I will say, if you work in a place where you have an infrastructure group and a DevOps group, that's like agile waterfall. It just doesn't work. it's not effective, right? Like, anyways.
Yeah, 100%. Like, when you talk to those two teams, they very often don't talk to each other. If that happens, right? And their whole mindset about the way apps get to production is just completely different. Like, it's two different worlds. So I understand that this is kind of silly in the idea that I've oversimplified this to a high degree, right? But if I'm a manager that's got budget, there's some truth to this too. Can we do this? Is a question that maybe you need to ask yourself.
Right.
And the question is, how do you do that? And that's what we're talking about tonight, which is KubeVirt. So KubeVirt is an open source project that basically allows you to run virtual machines in a Kubernetes cluster. So I'm probably already scaring people off here because they're worried about command line utilities and things like that. But let me try to simplify this. For any VMware administrators that have no Kubernetes experience or container experience here, let me try to explain this in a very simple way. Basically, what we're going to do is whenever we containerize any application, all we're really doing is putting a box around a process that's running on a server so that it, one, can't see other processes on the server, right? We have isolation, and that's done with a primitive in Linux called namespaces. And then we want to be able to set resources on that container as well, so that one container can't use all the resources on your server, right? We've learned this in the VMware days that you can have a noisy neighbor. You don't want to have one VM that's taking up all the resources on an ESXi host and starving the other ones for resources. And that's done through another Linux primitive called control groups or C groups, right? And so that's how we built containers up to this point. When we talk about virtual machines, all we're talking about is taking the virtual machine process and putting it in a container. So KubeVirt is a control plane that's going to manage your virtual machines, but we're going to put basically two processes in a container. This is libvirtd, which is a daemon that's an API daemon that sits in front of your hypervisor. So you can actually use libvirtd with VMware if you wanted to. You can have it. You could send commands and things and let it reconfigure for you. And then libvirtd is going to talk to QEMU, or the quick emulator, and KVM. So we're really talking about KVM here. And we're going to put those in a container process. Once we've got a virtual machine encapsulated in a container, basically, now Kubernetes knows how to manage it. So at this point, we've got something where we've got a different technology that now knows how to manage virtual machines sort of natively. We got to give it a little bit of extra help. I'm going to stop there and see if there's any questions.
Can you explain KVM?
KVM is a hypervisor. It's built into the Linux kernel, and it's been that way since 2007, I think. So basically, any of the main Linux distributions already have KVM built in as a kernel module. So we can use this right out of the box. So depending on what your Kubernetes distribution is, they're probably running on a Linux server. That Linux server probably has access to KVM. So you already have a hypervisor in your Kubernetes cluster. We just now need a way to orchestrate the VM across nodes in that cluster and let KVM do its work that it's been doing since 2007 or whatever.
Right. Chris, did you have a question? Because I've got another one, but I don't want to hog all the airspace.
No. Go ahead.
So back in my days of actually being responsible for production VMware, virtual machines were a precious resource that you loved and you maintained for years. Doesn't that, right? It's the old pets versus cattle, if that's ringing any bells. If not, It's okay. But how do those worlds meet up, right? Like if Kubernetes is, like if I'm thinking about Kubernetes from like a stateless perspective, or the ability to just deploy Kubernetes pods or containers, right? Like how do you kind of marry the long running gorgeous, beautiful, my favorite VM within that Kubernetes world? Does that make sense?
It does. Yeah, it does. I'm actually going to explain that in a few more slides, I think. If I don't, please stop me and ask that question again. Because that is a great...
I won't rephrase it that way, because that was a terrible way to explain it.
But yeah, that's exactly one of the transitions that has to happen, right? You're going to have to start running VMs in the Kubernetes way, but Kubernetes and KubeVirt are going to make this so it seems very familiar to you. Like things like a live migration or a vMotion type operation are going to look a little different, but they have the same outcome, basically.
Cool.
So this is all based on an open source project called KubeVirt. Shout out to any of the folks that are actually working on this project. I don't personally work on this, but I am a fanboy. So please keep working on this. It's great. And I'm seeing new stuff come out all the time. And one of the main arguments that I've heard about using something like KubeVirt out of the box is I'm not going to trust my main virtual infrastructure, which has got my crown jewels in it, to this brand new thing I've never heard of until, I was on the vBrownBag tonight, right? Which it's not.
That's totally how it works. We're like the breaking news of IT here.
Tonight might be your first night.
Yes. Yeah. And congratulations, you learned something new. That is awesome.
Yeah. But like KVM has been around since 2007 as an open source hypervisor. And my guess is you have used KVM somewhere along the line, maybe without even really noticing, right? It got added to Red Hat Virtualization, or Rev, in 2009. KVM was adopted by AWS for your EC2 instances in 2010. It was the default hypervisor for OpenStack. Nutanix was using it in Acropolis starting in 2015. Google's using it. Like, it's prevalent everywhere. KVM is in a lot of places. Even if you haven't directly been interacting with KVM, you probably have been using KVM and not really noticing it. So KVM is very mature as a hypervisor. It might not feel as nice and cozy as VMware did to us. But KVM's been around. It's been battle tested. Like, people have been using this for a long time, right? The new thing is running on Kubernetes with KubeVirt.
There is actually potentially an urban myth that when AWS was first building out the cloud, that they had actually approached VMware and was going to ask VMware to give them ESXi licenses to be their hypervisor. And VMware said, yeah, if you pay full MSRP. And AWS said, yeah, don't worry about it. We'll just use KVM instead. And I don't know if that's true, but it sounds plausible.
I'd never heard that before. But yeah, I mean, Amazon got the last laugh because they got to screw VMware with their, Amazon VMware thing. And anyways, all that's done now.
Yeah.
The Grim Reaper comes for all of us.
It sure does.
Sorry, Eric.
No, just imagine what would have happened if that had happened and then the Broadcom acquisition happened and now Amazon is now trying to figure out how to pay this bill too, right?
Right.
We got nuts, maybe.
Oh, that would be amazing. That would actually be a pretty great story to tell.
The Battle of Titans. Okay.
Yes, indeed.
Sorry, so, I apologize. I derailed.
I think basically to understand KubeVirt a little bit, we have to take a step back for most VMware administrators who've never touched containers or Kubernetes. So I'm going to take a step back. I'm going to talk a little bit about containers and Kubernetes, because I think once you understand how Kubernetes works, you'll understand how KubeVirt is facilitated. I keep muting my mic for some reason. Here we go. So what is a container? A container basically includes your application or your process, as well as any of the binaries and libraries that are needed to run that container. We package those together, and then we can run them basically anywhere we want to. That has a container runtime on it, right? So a container runtime, think of that as something like Docker, right? Docker is a very famous one that people run on their laptops and things. It's not really what's running Kubernetes usually, but they have similar things that do the same type of thing. Pulls down a container image and starts that image and runs a container. It's portable as long as they have a similar kernel on each container host, meaning I can deploy a container on one host and then redeploy that container on another host if they have a similar kernel. This shouldn't be too crazy for most VMware administrators. It's like moving a VM from one host to another host, and they have different CPUs or something. You can't really do that. But if they're close, you can get away with some of that stuff. And then, as we talked about earlier, containers are isolated from each other using Linux namespaces, so they can't see each other. They're just sharing the underlying host's kernel for anything that's not built into the container. And then containers are resource restricted by C groups. Okay, so that's basically saying you have this much CPU, you have this much memory, and that's all you're allowed to use. Okay, one of the things I think that a lot of folks who are getting out of the ClickOps world of, say, VMware and more into more of a DevOps world where things are done in the command line or in code is this idea of like immutable images and things. So when you build a container, you spend most of your time up front figuring out how that container is supposed to run. You'll build things like a Docker file that lays out exactly how that application is supposed to be packaged together. And then when you are ready to package that into a thing called an image, think of an image like a VMware template. The image gets pushed to an image repository or an image registry, right? And that's where our images sit until someone decides to deploy a container from that image, right? It's the same concept of a VM from a template. We now have a container from a container image, or and anytime we want to make changes to that original container image, we would then basically create a new image. We don't update the existing image. We create a new one. So if I have version 2 or if I have patches or whatever, I just build a new one from my code and push the image up. So now I might have 2 versions of the same application in my image registry. Both are available for me to download and run. And so in that case, when any time I need to make changes, they're made changes in that image up in the image registry, versus a virtual machine where you could have a content library or something like that where your VM templates are stored. When you patch a VM template, at least the way I used to do it, was you turn the template into a VM, you run all the changes you want to make on the template, and then you turn it back into a template again so that my VM's updated, right? And in most cases, you're probably just updating the VMs that are deployed from that template with regular patching or something, right? So you're basically modifying a running in production server when you're doing your patching and updates with a VM. In a container world, you're doing it before they ever get deployed. And I think that's a different change, because you have to change your thinking about the way that you would do software patches and security patches on a monthly basis and all those things. It's more work up front, but then you can redeploy these images multiple times over and over and over again. They don't change. You know exactly what you're going to get when they get deployed. But if you have to make a change, it might be more work for you. It's just less risk, I guess, is the way I would like to put that. What about the control plane? So the VMware control plane is pretty simple. We remember this. We've got VMware vCenter. It's a monolith, right? There's a virtual server somewhere sitting on maybe its own cluster or on its own node. And then you've got a set of ESXi hosts where your apps run. And then you deploy your VMs. If we juxtapose that with what Kubernetes looks like, you have something very similar. You still have a control plane. That control plane, though, is spread out across multiple hosts, typically in production. Which is kind of nice, because then if you lose any one of those hosts, you still have the control plane up and running, as long as you have 2 out of the 3 hosts, for example, as long as you got quorum. And again, we're running everything off of desired state here. So instead of issuing commands one at a time where I'm clicking on a UI, in this case, I'm submitting what I want my end result to look like, and then letting the Kubernetes engine in the control plane figure out how to make that happen. So for a VMware person who's used Terraform or something like that, this looks very similar. Chris loves it. So like,
yes, he is a sucker for a hashy call out.
Oh, the plugs. I love it.
But that's the easiest way for me to kind of explain this methodology of desired state is use Terraform. I apply it once. And if I'm making updates later, I apply my updates again and let it make the changes for me, right? I don't have to know how to get from A to Z. The control plane knows how to do that. I just have to tell it I want Z at the end, right? That's my end goal. And so the desired state typically looks like something like this. This is a YAML manifest for a pod. A Kubernetes pod is the most basic element that Kubernetes knows how to deploy. It contains your container image. So think of a container image. Basically, containers run. Actually, I don't want to make that comment, I guess. Containers basically run on a single node. Like you could run a VM on a single ESXi node, but that doesn't do you a lot of good. What you're trying to do is use something that's clustered your nodes together so that you can balance your workloads across multiple nodes. Kubernetes is doing the same types of things that VMware was trying to do. They're just defining that in the desired state. So here I've got a simple desired state YAML manifest that's deploying a container. You can see the image name is Nginx. So I'm deploying a web server basically here. And I'm calling this pod my pod. So my pod contains my container. And that's what Kubernetes knows how to deploy and move around and do all the fun Kubernetes stuff with. And it uses a control loop. So I'm basically saying, hey, I deployed this. I want to deploy this container, or I've already deployed this container. Does my current state match my desired state? If it does, great. Check it again to see if my current state matches my desired state, and keep checking it over and over and over again. So if something changes in my environment, it's going to need to change that for me. If it doesn't match my desired state, do work. I don't know what that work is. Like if I don't have enough containers deployed or pods deployed, or I lost a node, or whatever happened in my environment, or whatever's going on, if I'm not meeting desired state, the control loops have to fix that and make sure I'm meeting desired state. So what this means is it's building some of those things that we relied on from VMware, like vSphere HA. That's kind of built into Kubernetes already. If I lose a pod or a VM in this case, the control loop's going to say, the node went down, the VM is not online. I'm supposed to have a VM online, start a VM on one of the remaining nodes. That's vSphere HA. We're just doing it in a kind of different way. And so when you deploy this, it's got a scheduler in Kubernetes, and we're scheduling things the same way, similar ways that the vSphere scheduler is, right? I'm looking at resource utilization. I'm looking at which nodes are available to me, all of those things, and I'm distributing my VMs or my containers across the available nodes in my cluster.
Right.
And so, Damien, one of your questions was basically this pets versus cattle question, right? Like, how do I manage things that are spinning up and spinning down all day long and doing things without me interacting with them, versus the way we did things with VMware, where I built a VM once and I do the care and feeding for its entire lifetime. And it's, something I'm very attached to.
Right.
Well, Kubernetes has to be Kubernetes. When we use KubeVirt, we have to work around some of those things. So in this case, I could deploy a pod with a desired state manifest. It would get deployed to one of my worker nodes. That worker node would give it an IP address. Typically, pods use IP addresses that are DHCP. Doesn't mean they have to. I know that's going to turn off some VMware administrators that statically assign IP addresses on all of their servers. That was me when I was younger. But DHCP is typically what's used in Kubernetes. If that node goes down, obviously HA kind of kicks in because desired state's not met. Moves it over to worker node 2. And here you're starting to see that issue, Damien, where now I've deployed another pod because I said I needed another pod. That pod got a different IP address. And that's going to really make some people frustrated if they're VM administrators that typically statically assign everything, right?
I remember when we first introduced Kubernetes at a company I worked at, I want to say back in 2010s, the networking people lost their bananas. It was like, what do you mean? I just give me a range. They're like, no, you have one IP address and it goes to another IP address. And I was like, how long does it take you to provision an IP address? He was like, 2 or 3 days. I was like, absolutely not.
Yeah. Every IP address is precious. It's like that Monty Python song, right? Like, it's all sacred.
Yeah. And now one of the nice things about Kubernetes is typically if you're deploying it with pod networking, it's kind of natted from your network. So like you have the IP addresses of your nodes, but the pods that run inside of it, you don't really care what their IP addresses are. Once you start working with Kubernetes, you'll kind of get that.
Right.
So this is one of those challenges, Damien. And the way we solve that, at least for containers in Kubernetes, is we use this thing called a service. And the best way to think of a service in Kubernetes is it's like an internal load balancer inside your cluster. Mm-hmm. And the load balancer always knows where your containers are at. If they're starting up and stopping, if they're moving at different nodes, if they're getting different IP addresses, it doesn't matter. They're looking for containers that have a specific metadata tag on them, and then it knows how to access them. The service has an IP address that doesn't change, and it has a DNS name. So now I can reference my containers via DNS, just as long as I'm telling them to look for the service, and then the service figures out how to get it to the containers. And that lets me do cool things like I can add additional containers if I need more processing power, right? Or they can move around. I can delete one and my application will have any issues, and they can move around, right? We do this with nested loops. So the pod controller is the thing that deploys our pod and our containers. It gets information a lot of times from a replica controller. So, since I can do this with a load balancer type thing inside Kubernetes, what I can do is I deploy things in pairs. So then if I lose a node, I never have any outage. I don't have to wait for a reboot or anything to happen on another node. I have a second container running on another node. Always deploy things in pairs is the way that basically it's done in Kubernetes. And then you've got a deployment controller, which basically tells you how to update and do things when you make changes to them later on, right? So the point of this slide, though, is really that I've got one control loop saying do something, and that hands it off to another control loop who has to do something from that, and then it hands off to another control loop. That's how VMs work in Kubernetes. So what we do when we deploy a virtual machine is we deploy a VM config. That VM config deploys a thing called a VMI, and that's your virtual machine instance. It tells you what node and things that the virtual machine is actually running on at that time. And then the virtual machine instance deploys a pod. This is a standard Kubernetes pod, the same pods you're using to run containers. It's just got that KVM and QEMU processes running inside of it. Okay. The other thing, I think the main thing that a VM administrator is going to have to get used to is the way storage works in Kubernetes. So typically there's not this idea of shared storage where all of your Kubernetes nodes are going to get access to the same piece of storage like there is in VMware with VMFS, for example, right? The way it works in Kubernetes is I have a container pod. I have a persistent volume that gets created on a storage solution, your SAN, right? And then we map a PVC, which is a persistent volume claim. That claim tells me which persistent volume belongs to my container or my pod. We then nail up the connection between the persistent volume on your storage solution to the node, and then the container can access that persistent volume. If that container needs to move for something, I have to disconnect it from the previous node and reconnect it to the new node. So you can still have this idea of like shared storage, but it's not instantaneous typically, right? You typically have some sort of a thing where you have to sever my connection to my storage, start up my containers, and then reconnect to that storage. That's a little bit of a change for most people. But we do the same thing with a virtual machine. So now I'm deploying a virtual machine pod. It uses a persistent volume claim, and it connects to a persistent volume on the SAN. The persistent volumes for a virtual machine, though, are slightly different. Since a VM has to have its own file system for the operating system, we insert a thing called a disk.image, and that's actually your operating system image or your disk itself. So we're actually writing into this disk.img file that sits in a persistent volume. When we have a disk.img file in a normal Kubernetes persistent volume, we call that a data volume in KubeVirt speak. So we have data volumes, which is basically the backing disks for your virtual machines. And the way that works is, again, through control loops. KubeVirt deploys a thing called the Containerized Data Importer, or CDI. And when you deploy a VM, the CDI creates your PVC. It then reaches out to wherever you've defined where your image is at, right? So this is my boot disk, essentially. It's my operating system image that I have to go get from someplace. It could be a URL. It could be an image repository. It could be another PVC in your cluster that you're going to clone. All of those things are possible, but it basically pulls that image down and downloads it and puts it in the PVC for you. We call it a data volume. And then your virtual machine instance can access that data volume, and your VM can boot up because it has access to its own disks. The last thing I'm going to mention before I get into a quick demo, or we can see this, is live migration. So nobody is moving to a new virtualization solution unless they see that they can move a VM from one host to another host without it going down. The moment I saw my first vMotion, it changed my career. I'm not going back to a solution that doesn't have that if I'm doing virtualization. I don't know if I'm in the minority here, but I feel like that's table stakes at this point.
No, it totally is. It totally is. And those of us who've been around in the game for a while remember that like wow moment when they saw a VM move. And
look,
like
you didn't lose a single ping.
Right. It was like that was a very transformative moment. I think it was like a core memory for me. Like,
same.
Wow,
Same.
like that.
Same.
I just saw actual magic. You know.
Let me ask you this question, since we're on that subject. Did you ask him to do it again because you felt like you missed it?
100%. Yeah.
Yeah. I was like, wait, do that again.
one host back to the other host. I was like, okay, you moved it, now move it, because we all know that the restore is always harder than the recovery.
Yeah.
So yeah, I was like, make it jump back and forth, and they did. I was like, this is the nuts.
Yep.
I think it was ESXi 3.1.
Yeah.
I can't remember which one it was. It was way back in the day. No, it was GSXi. It was GSX. That's right. It was.
Oh
yeah.
wow.
It was
Wow.
GSX.
You're really dating yourself.
Dating yourself, yeah.
I am.
Some folks don't even know that ESX used to exist, right? But like GSX is even that's like when the magic was written.
Yep. So let's explain basically the juxtaposition of how live migration works, where we're talking about a VM thing that that VM that we love and care for throughout its entire life cycle, versus how Kubernetes works. We're just like, yeah, I'm going to delete that and create another one on another node. That's there's two things that are not in balance here. So the way it works in Kubernetes and KubeVirt is we have this solution where we've got our persistent volume on our storage. We have that PVC. We have a Virt launcher pod. Virt launcher pods are what is running our virtual machines. When we want to do a live migration, the first thing that happens is we spin up another Virt launcher pod. So we now have another container that's running our VM, and it has a claim, and that claim is to this same volume. Now, that volume needs to be read-write many, which allows multiple nodes to connect to that volume at the same time, because we're going to need to have two things temporarily, at least, have access to the same storage. So we're going to have these two nailed up. You're going to copy the memory footprint from one to the other. And then once that memory footprint has been moved over to the other side, it's going to remove the original one. So this is different from a vMotion, for example, where you have the same VM that has literally moved from one node to another node. In this case, I have a different pod, but my VM looks exactly the same. It's connected to the same storage. It's got the same memory. It looks identical, right? But if I look in my Kubernetes history, I'm going to see two different pods, basically. Mm-hmm. So that's how we kind of get those two things that are working together. Kubernetes is doing it one way. Virtual machines want to be run another way. This is how it makes them work together. And I think you've heard enough of that. And let's get into...
Before we get into the demo, I did want to address Nikhil's question. He's been waiting very, very patiently. Nikhil asks, perfect timing. I just finished setting up Cockpit, libvirtd, and KVM for my Kubernetes home lab. Shout out for getting a home lab up. Any advice on how not to break things?
I think actually my advice is the opposite. I think you should break things, mainly because you're going to learn a lot more. You're definitely going to learn a lot more when you're fixing those things. But like, it's a home lab. It's designed for you to make mistakes and figure things out like that. Do it here. And then, that is a lot better than going to work and doing it. Trust me, I've done both of those. One at home is much better.
So I'm in a home lab Discord of Two Guys Tech. They're another YouTube channel. Great folks. They talk about like change windows on their home lab because their home users get upset.
No,
like, that's not
that's not a home lab.
You don't need change controls because everyone is like doesn't want their streaming to go down. Like, come on now. Anyways,
follow-up question on top of that one. We've already defined the persona. We were painting the picture of the persona of the vSphere admin who loves his Windows operating system, loves his mouse, and loves clicking around. In order for that persona to get into KubeVirt and Kubernetes and the things, what things need to be in their head before they can like start thinking about a home lab? What would you recommend that they learn about?
I always go back to containers. Okay. At the end of the day, the virtual machine is running like a container in Kubernetes. I don't think Kubernetes is even that hard for people to get their head wrapped around. Containers, to me, at least, when I switched from vSphere to like doing things with containers is the thing that took me the longest to kind of get up to speed on. And it wasn't even necessarily like the process of like running a container or building a container image, but it was like just the way that you operate a container is just so much different. Like the way you build images, the way I'm, just doing day two type operations, like just kill that and let it build another one. Those types of things get you in a different mindset. So I would say, like, even if you're just running containers on your laptop or something, start with that, and that'll lead you into Kubernetes pretty quickly, I think. Once you know Kubernetes, I don't think KubeVirt really is a thing that'll take you that much time to learn at all. But I think Kubernetes is probably one of those areas that does take a little bit of time. And if you're, to be frank, if you're a VMware shop, you don't have any Kubernetes experience in-house, or you've not touched containers, this might not be the right solution for you until you've gotten some of that maturity. There are solutions that are out there that give you a UI and make some of these things easier, but at some point you're going to have to troubleshoot these Kubernetes clusters. Those clusters run containers. So even troubleshooting the cluster is going to require you to have some container experience and Kubernetes experience. So like, take a step back. KubeVirt is a couple steps down the road. You should look at containers first.
Okay. So the first step would be install Docker Desktop or Podman locally and start, go through the tutorials there, kick the tires on that, figure out how to get your first container going.
Yep.
Cool.
100%. And then Kubernetes, if you really think about it, is just a collection of container hosts, and we got to figure out a way to orchestrate across them, right? So containers get you, I think, the bang for your buck. Containers get you the best early on, right? You'll learn the most there.
Agreed.
I've got a quick question, and then we can jump to demo. And this is a gimme question. It's a softball. Can I run Windows VMs on KubeVirt?
Sure. Yeah, if you want to.
If you like hitting yourself in the head.
If you want to. Can you run ESXi on KubeVirt and then never mind.
You probably can. Yeah.
Probably.
Turtles all the way down.
Yeah. But yeah, KVM is a hypervisor. You're going to supply your own operating system for those. You can run basically any type of operating system you want because KVM is doing the work. It's not Kubernetes or Linux. It's KVM.
You're welcome. That was a very slow pitch.
Thank you, Damien. You always got my back.
Yeah.
So here's another one of those YAML manifests. This one looks a little scarier, like a virtual machine pod manifest looks a little scarier than the basic pod manifest I showed earlier in the slides. But YAML's relatively easy to kind of figure out just by looking at it. Most cases, you can copy and paste this from a lot of places. And I'll show you a little bit that you can kind of get some of this from a console. It's a little easier. But tells us we're deploying a virtual machine. That means KubeVirt's going to do some work on it. You name it, you give it some metadata here, and then you define what your virtual machine is going to look like. So I've got something that's easy to explain. So in our domain here, we've got requests for memory and CPU. Guess what that does? It tells us how many CPUs and how much memory is going to be available for your virtual machines. And then you've got a set of disks. So of course I have a root disk and it's using a VirtIO bus, obviously. And then we've got, don't do that. I have a cloud init disk. So even my cloud init script in this case is going to be a disk to KubeVirt. And then I'm also attaching a secret. So Kubernetes allows you to create secrets in Kubernetes as well. And I'm basically mounting that secret like it's a disk. And that secret has my SSH key in it so that I can access that virtual machine after it's been deployed, right? So those are kind of the basics here. One I wanted to point out was this run strategy. So there used to be a field here that was either basically running or not running. It was on or off. Can you guess why that doesn't work very well with a desired state manifest in virtual machines?
Well, I could come up with a couple of scenarios. Sure.
If you set that to running and someone logs into the virtual machine and powers it off.
Yep.
Kubernetes is going to go, hey, that's supposed to be running. Start it up. So you have this issue right there. So they had to change it. Now it's called run strategy. And now you can set it to like always, which it'll do exactly what we talked about. Or in this case, it says rerun on failure. So I'm going to go ahead and deploy this quick. And to deploy things in Kubernetes, you can do kubectl apply file name. And now it is applying to my Kubernetes cluster. So that's really all I had to do. I had to figure this thing out, this YAML manifest the first time, but now I can run it over and over and over and over and over again with this one command, which is, again, some of that change that you're not maybe used to.
Is rerun on failure an equivalent of VMware HA, or is it not? Is HA handled more at the Kubernetes level?
Yeah, so it's basically using desired state here, but it's going to rerun on failure, meaning if the node or whatever that I was on fails, it wasn't supposed to be turned off, so turn it back on. If someone logs in and manually shuts down the virtual machine, don't do anything with it. Leave it in an off state.
Okay, yeah, I didn't know if it was saying like if the VM crashed or if like the underlying system was unavailable, then to restart it. So okay.
Actually, I don't know about the crash. Like if the operating system crashes on the guest VM, I think it reboots it, but I'm not 100% sure on that. That's a good question. So once you've deployed this, I can do things like interrogate my Kubernetes cluster to see what's going on, and I'd run kubectl get VM on my namespace, which I also named VMs, which was kind of stupid probably. But that's where all my virtual machines are running. And you can see I have a rel VM. It's been there for 75 seconds. It's got a status of running, which is great. That configuration doesn't tell us a whole lot. It just means that we said we wanted to deploy a VM. Mm-hmm. We can also do kget vmi -namespace VMs. And this is the virtual machine instance. So the VM created the virtual machine instance. The instance is the running version of that virtual machine. And that means it has to have an IP address. It has to have a node. And in this case, it's running on node 2. And then we can finally look at pods on the same namespace. And you can see I have a pod called Virt Launcher. And then it's got my VM name and then a unique identifier here at the end, right? And it's in a running state. There's a command line tool here. I don't think I'll go into it because I don't know if we got enough time. But like you can run things like virtctl. This is a thing specific to KubeVirt where I can run virtctl SSH, and I can SSH into this virtual machine using that SSH key that I mounted to that virtual machine, right? So that I can still access that. But I think it might be better for some of our VMware folks to see this in a UI. So here's my virtual machine UI. In this case, I'm running a Kubernetes cluster on
He's
Red Hat.
not. that is a very busy user interface.
I would agree with that. There's a lot of information here in one place.
It is, yes.
When you deploy OpenShift virtualization, which is their version of KubeVirt, right? It's using upstream KubeVirt. You can look at your virtual machines here, and it gives you a little bit better UI that you might be more familiar with, right? And here you can see I've got a namespace called PX Barbecue and a VM I've already deployed there. And I've got this rel VM that we just deployed, right? And it's got things like a console. I can see what's going on in the console here. I can actually look at the YAML. So if I deploy something from the console, I can copy and paste that YAML and reuse it. And then I can make configuration changes to that VM as well. But the thing you guys want to see is it move, right? So here's my rel VM, and it's on node 2 at the moment.
Yep.
And hopefully through the power of live demos will let me do a migration and click compute.
Have you done the necessary sacrifices today for live demos? I don't know. Am I breaking up?
No, I can hear you.
Oh, okay. I was asking if he's done the necessary sacrifices for live demos.
Well, I can't answer for him. I don't know.
I think I did them all.
Okay,
There's a task list, and I might have missed a step.
Yeah. Did you wear the robe and like ring the bells and stuff? Yeah.
Kill the goat.
So now it's running on node 3. And of course, the question you're going to ask me is, can I pick which node I'm going to migrate to? Currently, no. That's a feature that's being added, from what I understand, to upstream KubeVirt. But right now, you're still allowed to move your virtual machines between nodes. You just can't necessarily pick which one. So that's a super high level overview of like the KubeVirt project and how Kubernetes works with virtual machines, and like an opportunity for you to perhaps switch your way of thinking about how you're running your virtual machines in your environment.
Maybe I've gotten too far away from vSphere, but it does. I mean, to my brain, it's It's not that this is easier. But all the motions are the same. I mean, we've got FT, we've got HA, we've got the things. They're just slightly different. You're still remember back in the old VCP class where they talked about how HA worked and how it was the memory that flipped the bit over and then it hydrated all of the RAM. Well, it's doing the same thing, but you're hydrating a disk. You're basically restarting an operating system and then cutting over the stuff on the back end. So the motions are all the same. It's just where you're not hydrating all of the RAM, you're just hydrating the operating system effectively. So, I mean, I'm a dummy. If I can figure this out, then any vSphere admin can figure this out.
No, I don't believe that FT is available. Am I correct?
No. What I'm saying is that the analog for FT is there. Like if for fault tolerance, you've got two systems running, and they're both at the same time. So if one dies, the other one just stays alive, and everything cuts over to it. Here, you've got your PVC on the back end, and the operating system just dies. I mean, yes, it's not going to be instantaneous, but containers spin up so fast that largely you're not going to notice it. And if you've designed your app properly, you've actually got multiple front ends, so that all you're doing is cutting state over from like session control or whatever.
Right. And ironically, one of the things what you're bringing up here is like, I would just do that in containers. I've moved on where like I want to use a container to do a lot of these things as opposed to actually running a VM. The point you just made is right, except the VM still has a boot time, right? So the container spins up very quickly because it's just starting a process.
So it doesn't need classic FT. It does. It's accommodating for that by virtue of speed.
It's more like HA than FT than fault tolerance for those that don't know all the acronyms. But yes, it's more like high availability than fault tolerance from a VMware perspective, right?
Yeah,
agreed.
It is.
Okay,
but the same premise applies. Like if I'm running 2 web servers, I can do that in Kubernetes very simply and use that service to load balance traffic between them. The server, like the whole application is fault tolerant now because I can lose part of it, but my individual pods aren't, right? So the virtual machines won't necessarily be fault tolerant. They'll be high availability or highly available, but
right.
You can.
But the application would be fault tolerant because of the load balancing.
Right.
Boy, I feel like we've gotten very specific very quickly.
Yeah, sorry about that. That's my fault.
It's okay.
I told you I was a dummy. I
This
have
is
to spell these things out.
Podcast, Chris.
What? No, it's not.
Yeah,
this is where we talk about my feelings. Okay.
Does OpenShift do anything with OpenStack, or is it just they happen to use the same name?
Yeah, different. So OpenStack, OpenShift, 2 different things. Just I assume it's part of the branding from Red Hat.
Okay. Right on. I was just curious if it was some sort of OpenStack thing under the covers as well.
Yeah, I don't
for
think
those
so.
who might be curious. Okay.
They're both open source, but one is shifting and one is stacking. It's 2 entirely different things.
Different motions. Yeah.
Like
totally. Bending and twisting.
Yeah, you can't do that after 50. You're going to throw something out. Are you kidding me?
Jesus, yeah. I mean, just sleeping is a
give
risk
yourself
to your
a
health.
hernia. Okay, enough of that.
This has been great, Eric. So can we plan to have you back in approximately like 12 months? Because that's weren't we talking about this months and months ago?
Oh yeah, because I think I ran into Chris at Red Hat Summit, which was like I think in May.
Yes.
Okay.
And I was like, yeah, let's do this, but like I need to put it off until towards the end of the year. And am I the last person of the year that's actually presenting? I don't know.
Oh no, we've got several more to go between now and the end of December. But it's long story short, I had a bunch of surgeries. Things have been all a flutter because of calendaring and knee surgeries and stuff like that. So, we're happy to have you on, and we can have you on sooner than 12 months.
Yes. Mark your calendar, Eric. We expect you back in a reasonable amount of time.
Okay,
right.
I think this is great. I used to see you guys once a year. I think we should probably bring that back up again. So I make sure I see you guys at least once a year, just on the podcast instead.
Well, I'll see you next week
for sure.
I'll see you.
That's true.
I'm gonna be in Atlanta. We should go to the aquarium together. That'll be fun.
Day 0 event for my company is at the aquarium. So yeah.
Is it really?
Yeah, it's gonna be cool.
Okay, I'm gonna ping you. I need to get the link for that.
Okay.
I'm so
All right.
jealous.
Well,
I will not be in Atlanta. I will be in Central Texas yelling at clouds.
oh,
Based on what I'm seeing about airlines and the TSA and, the government shutdown, none of us might be in Atlanta at this point.
That's why I'm flying in a day early, just in case. I was trying to cover my bases with all that nonsense. All right. Because only Nikhil, if you're still there, Nikhil was the only person to chat in the actual chat thread and ask a good question. Nikhil, you are the winner of this week's $50 AWS compute credit. So congratulations, Nikhil. If you will, please either DM me on YouTube via the DM feature or find me on LinkedIn or just Google Mistwire, Mistwire. I'm like the first 5 pages of Google responses for that. So
don't
get
look
in
at the
touch with
sixth.
Don't look at the sixth one. It's awful. It's terrible. Run away.
It's too spicy.
NSFW. I forget. So, Nikhil, congrats. Get in touch with me. I will get you your compute credits, and you can play with some AWS compute stuff. Mr. Shanks,
on KVM.
Exactly.
Yeah.
You know what? You can, you can spin up AKS clusters. You can get all of your Kubernetes experience out in one go, and then put KubeVirt on top of it. So, Mr. Shanks, I'll see you next week. Everybody else, have a wonderful evening, and we'll see you again next week. Bye.
Adios.